Have you ever wondered what makes a ball roll down a hill? It's not like the ball suddenly decides to take a leisurely stroll. Something gives it a nudge, a spark. This, my friends, is energy flexing its muscles. It's like the undercurrent in a river, unseen but powerful, propelling everything in its path. It's the invisible force that sets things in motion, a silent player in the game of life. So what exactly is this energy we're talking about? Before the ball starts rolling, when it's just sitting at the top of the hill, it has something called potential energy. Think of it like a sleeping giant. It's the energy an object has because of its position. Like our ball at the hilltop, it's high up, ready to roll down at any moment. It's like it's holding its breath, waiting for the right moment to release all that energy. So potential energy is like a sleeping giant. It's there, but we can't see it until it starts to move. But what happens when our ball actually starts rolling down the hill? Well, as our ball begins its descent, the potential energy it had stored up starts to transform into kinetic energy. Kinetic energy is the energy of motion. It's the force that keeps our ball rolling, turning, and tumbling down the hill. It's the energy that's in action, that's doing something, just like a sleeping giant waking up and starting to move. So, kinetic energy is like the giant waking up and starting to move. So, potential energy and kinetic energy work together to make the ball roll down the hill. But how do they balance each other? Well, it's all about the conservation of energy. The total energy of the ball remains constant, it just changes form. As the ball loses potential energy while rolling down, it gains an equal amount of kinetic energy. It's like a perfect trade-off between the two forms of energy. And that, my friends, is how a ball rolls down a hill. It's all thanks to the amazing balance between potential and kinetic energy.